When a quadratic equation is in standard form, like this one was here, we saw that we could use transformations to graph the parabola, and the vertex was really easy to see, so was the axis of symmetry. But most of the time, we're going to run into equations that look like this, where we don't have that quantity in parentheses to tell us what the x value of the vertex is. And it's all multiplied out, so we can't just pick off the y value of the vertex either. So we need something else called the vertex formula to help us find the vertex. And we need to do something else to graph the equation. So we're going to take it through 5 steps, and I've written the steps here, and we'll go through each step as we graph this quadratic function. So the first thing we've got to do is find the x value of the vertex, and we're going to use a new formula called the vertex formula. That formula is x equals negative b over 2a. Now, at the beginning of the semester, we learned about the quadratic formula. And remember, in the quadratic formula, a was in front of x squared, b was in front of x, and c was out to the side. And this is the same a and b that we use in the quadratic formula. So let's notice right here, I'll use my draw feature, that a is a 1, b is a negative 4, and we really don't need c for our vertex formula, but of course c would be a negative 12. All right, so the first thing we're going to do is step 1, we're going to plug into this vertex formula negative b over 2a. So we'll have negative 4, and I'm sorry, my dog is going crazy in the background, and then 2 times a, so 2 times 1. And that gives us a positive 4 on top and 2 on the bottom, which is 2. All right, so the x value of our vertex is 2. We want to plug this 2 back into our function in number 2 to get the y value of the vertex. So let's plug 2 into our x values of our function. We will have 2 squared minus 4 times 2 minus 12. 2 squared is 4. 4 times 2 is 8 minus 12. All right, so let's see. 4 minus 8 is negative 4. And negative 4 and negative 12 gives us a negative 16. So our vertex is the point 2, negative 16. All right, now let's go to step 3. Let's find the y-intercept. Now we've done x and y intercepts with absolute values before, so let's do it now with this quadratic function. Remember, to find a y-intercept, we put 0 in for x. So let's put a 0 into our function up top. So it's going to go into all of our x's. We'll have 0 squared minus 4 times 0 minus 12. And notice that this term and this term right here become 0, so we really get minus 12. So our y-intercept is 0 minus 12. You might also notice that there's a shortcut to finding the y-intercept if everything is multiplied out in the quadratic function as it is here, or we don't have any parentheses or anything that can be multiplied out. Our y-intercept is always c, always this number out to the side. Okay, so we've got our y-intercept. Step 4 is to find the x-intercepts. And recall when we were doing the absolute value x-intercepts, to find x-intercepts, we set the whole thing to 0. So let's set x squared minus 4x minus 12 to 0. And let's solve this. Now, of course, we could use the quadratic formula. We can always use the quadratic formula to solve a quadratic equation, but this one does in fact factor. So let's factor it. Factors of negative 12 that add to negative 4. Well, that's a negative 6 and a positive 2. And let's set both of those to 0. And this one gives me a positive 6. And this one gives me a negative 2. Now let's write those as their actual points. This is the point 6, 0. And this is the point negative 2, 0. All right, so let's go back our last step. Plot the points that we have and draw the graph. And we're going to use the axis of symmetry to help. Now let's remember all quadratic formulas, quadratic equations, things with an x squared as their highest exponent are going to be parabolas. All right, so we're going to plot all of the points that we actually have. All right, so let me draw. And probably ought to make this longer. All right, now let's notice that my vertex is way down with a y value of negative 16. So I'm going to scale the y-axis by 2. So this will be negative 2, negative 4, and so on. Negative 6, negative 8, negative 10, negative 12, negative 14, negative 16. So let's just keep in mind that this is negative 16. Now let's try to put these values out here. Now I'll scale my x-axis though in the normal way. So 1, 2, 3, 4, 5, 6, and I'll go back with the negative 1, negative 2. So notice we can scale our x and y axis in different ways. We cannot scale a single axis though in different ways, but we can do each of the two axes in a separate way. All right, so let's go to the vertex. It's 2, negative 16. So let's plot that point. 2 is here, and negative 16 is here. And I'll go ahead and plot. My vertex is right there. Now, to help me a little bit, I am going to draw the axis of symmetry as a vertical dotted line going through that vertex. Okay. So there's my axis of symmetry. All right, now let's go back and let's plot the other points that we have. The y-intercept was 0, negative 12. So let's plot that. 0, negative 12 is right here. Now, let's notice this distance away from the axis of symmetry. So I could use the symmetry of the graph to go on the other side of the axis of symmetry, approximately the same distance away, and draw another point at the same height right there. All right, and then Let's plot our two x-intercepts, 6, 0, and negative 2, 0. So here's 6, 0, and negative 2, 0. And now notice if we draw the graph through these points, well, I kind of messed up as I was drawing there. But there's the graph of our parabola. And our parabola should look nicely symmetric when we're done. If it doesn't, we've messed up somewhere along the way up here in one of these steps.